Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're in Unit 6, looking at lessons 12 and 13, linear functions from a table. So when we're given a table of values, being able to write the linear function, write the equation for that linear function. And we're just going to jump into some examples here. In our first one, it says the first 5 terms of an arithmetic sequence are 3, 11, 19, 27, and 35. We want to write the function f of x to describe the xth term of the sequence. So basically we want to write what this function looks like, f of x equals. Well, so when we talked about arithmetic sequence, we're looking for that common difference. And so each time this is increasing by 8. And we said that that common difference was going to be our rate of change, or our slope. So 8 times x is that's going to give us that next term. What we don't have with that then is, how do we get that first term? Well, so if you think about the first term, x is 1. And so when I plug in 1 for x, 8 times 1 is 8. But I need that first term to equal 3. So to get to that from 8, I would have to subtract 5. And so this is going to be our function. And we can always try it with these terms. So that's the first term. My second term should be 11. So when x is 2, 8 times 2 is 16. 16 minus 5 gives me the 11, and so on. And so that's going to be our function. Our second problem here, we're given a table and we want to write an equation to describe that data. And so again, we want to find the slope. We want to use the y-intercept if we have the y-intercept. In this case, our table doesn't show us the y-intercept. But if we look to find the slope, the difference between our y values, negative 16 minus negative 7. Well, negative 16 minus negative 7, that's the same as negative 16 plus 7, which would be negative 9. And then if I do negative 4 minus 1, and actually I'm going to change the direction of that. So when I go from negative 16 to negative 7, I'm adding 9 to go from negative 16 to negative 7. To go from negative 4 to negative 1, I am adding 3. And so change in y over change in x, 9 over 3, my slope is going to be 9/3, which is 3. So every time x increases by 1, y is increasing by 3. And so if we use that idea here, I could use point slope and just pick a point that's here. Let's just choose this one, y minus 2, which is the y value there, equals the slope times x minus the x value, which is also 2 here. And so then I could simplify this to get it into slope-intercept form. Start by distributing that 3. So 3 times x is 3. 3 times negative 2 is negative 6. So y minus 2 equals 3x minus 6. And then if I add that 2 to each side to get the y by itself, I get that y equals 3x minus 4. And so this is my equation. And I'm going to go ahead and write it with the function notation. But again, I could check and see if that makes sense. Well, we said the slope was 3. And so if I add 3 to negative 7, I get negative 4. that makes sense that that's going to be my y-intercept. And if you plug in any of those x values into this equation, it should give you the f of x value that we have in the table. All right, last one here says a freight train departs from one train station to its destination at a constant speed. Suppose the distance the train is from the station in miles is represented as a function of the number of hours after the train departed from the train station. All right, and so if the graph of the function passes through these 2 points, 0.5, 135, and 281, what's the distance between the train station and the freight train's destination? All right, well, let's start again by finding that slope. So the difference between my y values, 135 minus 81, difference between my x values, 0.5 minus 2. And so 135 minus 81 is 54. 0.5 minus 2 is negative 1.5. And then let's go ahead and simplify that. 54 divided by 1.5 is 36. And so negative 36 is going to be the slope. And let's think about what that slope means. So that is the number of miles per hour. So it is closing that gap by 36 miles per hour. And so the question that they're asking here is, what is the distance between the train station and the destination? So again, a few ways we could do this. We could create an equation. So if I use my point slope, y minus the y value from a point equals the slope times x minus the x value, which was 2. And now we're going to distribute so that we can simplify and solve. So y minus 81 is equal to negative 36 times x, and negative 36 times negative 2 is positive 72. And then I would add this 81 to each side, so I get y equals negative 36x, and then 72 plus 81 is 153. And so this is the slope-intercept form, and that means that 153 is the y-intercept. So when x is 0, so when my time is 0, the distance was 153 miles. And so that means that the distance between the train station and the destination is 153 miles. So that's one way that we could find it. We figured out what that slope-intercept form is. Another way that we could have found it is we said that after a half an hour, we were 135 miles away. Well, we know that we're going 36 or negative 36 miles per hour. So that means in a half an hour, we would go 18 miles. Well, if we went 18 miles in that half an hour, that means that 18 plus 135 is that 153 miles. That's our distance. So again, several ways that you can approach these. Hopefully those are making sense for you. If you do have questions, though, please let us know. Thanks, everybody. Have a great day.